Hey everyone, welcome to the final set of notes for chapter 7.3 and 7.5. I'm just going to get into it, so let's get started. One problem we often come across in the plurality method is what's called insincere voting. And all that means is a person doesn't accurately say what their first choice is. They instead lie in order to get a better outcome. If that doesn't make sense, consider the following example. Imagine your neighbor is running for mayor, and you think that they're the best person for the job. But the problem is that your neighbor's not actually that popular. Maybe their policies aren't super popular, or maybe they just haven't been advertising to the rest of the neighborhood properly. But it's pretty clear to you that your neighbor isn't going to win. Well, what do you do? Well, the problem is if you vote for your neighbor is going to be a wasted vote. You're going to basically tell the world that your neighbor is important and you will have no impact on who will be mayor because, well, you know your neighbor isn't going to win. So instead you vote for your second choice who actually does have a good chance of winning. This is a thing that people do all the time. And in real life, when you talk about third parties in the United States, oftentimes people are concerned that voting for a third party might cause some problems, so people might engage in what is called insincere/strategic voting. And this kind of behavior is often blamed on the fact that your second choice doesn't actually affect the election, because in a typical election, they don't ask. So we have a solution to this problem. It's called instant runoff voting. And this is similar to plurality, but we also to have some extra steps. And this is also known as plurality with elimination. So here's how it works. Step one, everybody fills out an entire preference ballot. Instead of just asking who you think is your top choice, we ask all of your choices. Step two, if somebody has a majority, obviously that person should win. So they do. Step three is, well, the person who has the lowest number of first choice votes, we eliminate them from the competition, and anybody who voted for an eliminated candidate as their first choice, well, we look to their second choice, and that's going to become their new first choice, so to speak. And, well, we keep doing this until we find a victor. And that's it. It's a little bit more complicated than plurality, but it's not that bad. Let's think of an example. So let's look at our example. We have an election between Alice, Bob, Carol, and Dennis. And we're going to be using instant runoff voting. Because we need to talk about a majority, we should make sure that we know how many people voted. In this case, 12 plus 11 plus 10 plus 7 people voted for a total of 40. So in order to get a majority that's over 50%, we're going to need slightly more than half, and half is 20, so we need 21 votes. So nobody has 21 votes right now for first place, so we have to look to Dennis, because Dennis has the lowest popularity, so we're just going to remove Dennis from the ballot entirely. And that's what this looks like. You can now see that the exact same votes are cast, but now Dennis is no longer on the ballot. So you'll also see that Carol, Bob, Alice is on the thing twice, and that's because Dennis was in those columns before, and now Dennis isn't. So we're left with repeating terms, which is okay. Carol is going to get an additional 7 votes that she didn't have before, because Dennis is no longer in the race. But that's actually not a majority, because Carol only has 18 votes. So we have to look to who has the lowest number of votes, and that's Bob. Bob has 10 votes, and Bob is eliminated. So now we're left with 2 sets of votes, most of which say Carol Alice as opposed to Alice Carol. And, well, Carol has 11 plus 10 plus 7. That's 28 votes. And Carol wins the election because 28 is more than 21. Well, it's greater than or equal to, and that's the important part. So let's talk advantages. The big advantage to this method is that even if your first choice isn't picked, that doesn't mean that you don't have an impact on the election. In fact, 50% of the voters at least are guaranteed to have had a vote that directly helped pick the candidate that wins. And there's no need to have any kind of strategic voting because, well, your vote counted. And this is true regardless of the number of candidates and any stuff like that. So that's kind of nice. So let's think about disadvantages. So let's specifically talk about Bob. Now you'll notice that in our previous example, Carol won. And had we gone with plurality, where we just say whoever has the most first place votes wins, then we would have said that Alice wins. But now let's consider this Bob guy. Well, according to the preference of everybody, 28 people ranked Bob higher than Alice, 22 people ranked Bob higher than Carol, and 21 people ranked Bob more than Dennis. So that kind of means that Bob is a Condorcet winner, and that just once again means that he's preferred in any head-to-head matchup. So that criteria we mentioned from last time, the Condorcet criteria, which just says that if you have a Condorcet winner, they should win, that clearly didn't happen, so this fails the Condorcet criteria. Also, if you have some homework problems, we'll address this as the head-to-head criteria. It's the same thing. Just a quick heads up there. Now, it's worth saying that the previous example also had the Condorcet criteria issue, but now we have a new problem that comes exclusively with this new solution, and that's called the monotonicity criterion. So we're going to have to talk about a specific election, so let's talk about this one with instant runoff voting. Now, if you see, A has 18 first place votes, B has 17, and C has 11 plus 13, which is of course 24. And B, well, B loses because they've got the least votes. So if you think about it from here, well, the only thing that changes about the election now is that the people who voted for B first, well, their votes go transfer to A, so A now has 18 plus 17 votes, and that ends up being a majority. So A wins. Good for A. So let's come up with a weird example. Now, let's say that in retrospect, we decide that the previous election didn't work properly and we need to run it again, but this time, those CAB voters, that third column of votes, 8 of those 11 voters, they decide actually A is the better candidate, and they're going to change their vote to make it so that A is higher. So that's what this looks like. So we still have the original ACBs, but now we've got a new batch over here with 8, and we still have 3 from the old bunch. So obviously this election is different, so we have to now consider what happens. Well, now A has 26 votes, so that's not a majority. B has 17 votes, not a majority. And C has 16 votes, not a majority. But more importantly, C has the lowest number of votes now, so we actually kick them out first. So we eliminate them, and if you notice, by eliminating the C, B gets an additional 13 votes, giving it a total of 30. And that is a majority, so actually B wins this election. But A, as strange as this was, received more positive feedback. People liked A more in the second example but B won. Okay, so the public favors A more, but B wins. What's up with that? Well, this is just a weird quirk of this particular voting system known as the monotonicity criterion, which says that if people change their vote to increase a preference towards a particular candidate, that shouldn't harm that candidate's chance of winning, which is to say, this thing that just happened should not happen. And again, these things don't have to be true, but we kind of feel like they should be. Because, well, that seems pretty reasonable. If I like a candidate more, of course they should do better. But in this example, that's not true. It's not always violated by instant runoff voting, but it can definitely be a thing that pops up and therefore a flaw. And it's kind of unique compared to the, it's a kind of unique problem to addressing more than one of your choices. But I do feel like I need to say this. On the homework, quiz, and test problems, there is there are a couple questions that address the monotonicity requirement. Don't say that this condition is violated. It's not the right answer. It's a weird quirk. Um, there's not a really good way to check for it because this example is very specific. But don't say that it has been violated. You'll get the question wrong. Okay, so let's try to fix that with a better system. Okay, the problem is we still want to address the entire preference ballot because otherwise we kind of feel like we're missing out on a lot of information. So let's talk about the board account. So this method works pretty simple. The person's last choice, well, they get 1 point. Next to last choice, 2 points. And we keep doing this. So like if the third to last is 3 points and so on and so forth until you get to the very top choice. And the person who has the most points wins. So if you have a voter picking your top 3 candidates, then first place is going to get 3 points, second place is going to get 2 points, and third place is going to get 1 point. And if you had top 5 candidates, then first place would get 5 points, second place would get 4 points, third place would get 3 points, and so on and so forth. Let's give an example. So in our previous example, this was the one that had some problems from before. Well, let's apply the board account and we can calculate the point value. So remember, the candidate's points is going to be 3 times your first place votes, 2 times your second place votes, and 1 times your third place votes, and you just add those together. So that means that A is 3 times 18 plus 2 times 17 plus 11 plus 1 times 13. That's 123. I recommend just plugging these into a calculator. B, that's 3 times 17 plus 2 times 13 plus 1 times 18 plus 11, which is 106. And again, this is just being based on your first, second, and third choice. First choice, of course, gets 3 points, second choice gets 2 points, and third choice gets 1 point. And finally, for C, well, C has 2 different votes. That's 3 times 11 plus 13, plus 2 times 18, plus 1 times 17. That's 125. So C wins, because C has the most points. And I think it's kind of interesting that in the previous example, if in the previous example, a different person won in each way. So it's really worth noting that each of these versions will result in a different outcome. And that's kind of neat. Okay, but the board account isn't perfect by any stretch of the imagination. So let's look at this example. It's even simpler. Okay, so well, they're first place, so they get in the first column. So A gets 15 times 3 points there, and then their last place for the other two columns, so that's 9 plus 3 all times 1, and that's a total of 57. So A gets 57 votes. B, if I do the same strategy, well, B's in first place twice, so 9 plus 3 times 3. All plus 15 times 2, because they won second place once. And that's 66. And C, well, that's 9 plus 3 times 2, plus 15 times 1. Same kind of process, and that's 39. So if we just compare the numbers, B's got the most points. They've got 66. But notice that A won 15 first choice votes. And that's actually 55% of the votes, which kind of feels like a bad thing. In this case, we actually would say that the majority criterion was violated, which just says that if a majority leader exists, then they should definitely win the election. Like if you win by a majority, well, obviously you should win, right? But they didn't. So the majority didn't win, but that would mean that the Condorcet leader didn't win, because if there is a majority leader, that is the Condorcet leader. So this fails the Condorcet criteria too. But that's true for everything so far, so that's not the worst thing in the world. But one interesting problem with the board account that doesn't necessarily translate into a criterion is that this kind of implies that your second choice is almost as good as your first, and that's definitely not true all the time. Maybe you like one thing really, really intensely, but everything else sucks, and your second choice ends up getting more points than they probably deserve in your eyes. So that can kind of suck. For the record, the board account is often used to talk about things like sporting events where that problem doesn't exist, because oftentimes when comparing something like athletes, you don't necessarily have this as a problem. Okay, so the Condorcet criteria is kind of a hard thing to satisfy. And even though it seems kind of crazy to talk about, there are ways to make sure that it passes. One way was done on purpose to specifically solve this problem. It's known as Copeland's Method, and it's kind of similar to the board account in that we give everybody points. Specifically, just like the Condorcet test, we're going to have to compare every candidate to every other candidate. Then we say for every pair, the more liked candidate gets 1 point, and if they tie, both candidates get half a point. So let's look at an example, specifically this one. So if we compare Alice and Bob in our first example, well, Alice has 12 votes for the first column because they were ranked first, but they lose the second and third column. Bob is more favored there. So actually it turns out that 28 people think that Bob is better, which is fine. So Bob is going to get a point. Now we have to compare Alice and Carol. Well, 12 people liked Alice to 28 people liking Carol. And again, we're comparing them. We're just pretending Bob doesn't exist for this example. So it's just going to be Alice versus Carol. And in this case, Carol wins. So Carol gets 1 point. And lastly, we've got only one other pair to compare, which is Bob and Carol. And 22 people think that Bob is better, and 18 people think that Carol is better. So Bob gets a point. So Bob has 2 points, Carol has 1 point, and Alice has 0 points. So Bob wins. Pretty straightforward. Let's pick a slightly more complicated example. and apply Copeland's method? Well, we have to compare A versus B, A versus C, A versus D, and then B versus C, B versus D, and finally C versus D. For A versus B, well, if you look in columns 1 and 3, A is ranked lower than B, but in columns 2 and 4, A is ranked above B. So that's actually a 4 plus 6 versus 5 plus 5, which is 10 v 10. So that's actually a half a point to both of them. Okay, what about A versus C? Well, 14 people said that A was better than C, and the remaining 6 said that C was better than A. And you can see that that's columns 1, 2, and 4 said A was better, and column 3 said C was better. A versus D, well, column 2 says that A is better, but 1, 3, and 4 all said that D was better. And so, D wins and gets a point. Okay, B versus C, same kind of idea. Well, 4 people said that B was better, but that's only in the first column. And the second, third, and fourth all say that C was ranked higher than B. B versus D, well, 15 people said that B was better, and 5 people said that D was better, and that specifically was in the last column. And finally, C versus D, well, that's going to be the second and third column both say that C was better, but the first and fourth say that D was better. So specifically in this exact example, A actually comes out with 1.5 points, B has 0.5 points, C has 2 points, and D has 1 point. So, turns out, C wins. How great is that? And, well, that's Copeland's method. But what if D didn't run? So this is the exact same chart, but I've removed D entirely. So in fact, you're going to see ACB is represented twice, and that's okay. So now A versus B is the exact same matchup as before. So 1/2 point to both of them. A versus C, well, that's 16v4. That's still 1 to A. B versus C, well, that's still 4v16. Like these relationships have not changed because none of them were addressed because D quit and none of these are D. But that's it. So that's 1 point to C, 1 point to A, and oh yeah, and that 1/2 point to A and B. So A actually has 1.5 points, and B has 0.5 points, and C has 1 point. Well, that means A wins. But C won last time. That's kind of strange. That means that we got rid of D entirely from the entire thing, and the event changed, the outcome. But D didn't win. It wasn't like D was first place. D did pretty terrible. Instead, we say that as weird as this sounds, we have a criterion for this, which is the independence of irrelevant alternatives, which basically says that if somebody who didn't win gets removed from the election, the winner shouldn't change, because that doesn't make sense. And once again, these do not have to be true, but we kind of feel like they should be. And in this case, this ended up not happening. But what's the best method? I spent a bunch of time talking about voting theory, and every time I keep bringing up some weird quirk that ends up feeling like it shouldn't happen in some fair election. But this ends up being a problem with voting theory, and we've mathematically proven it. Not us, a different person. Specifically, it turns out that all of the criteria I've listed up to this point show up in every system in some capacity. They don't always show up every time, but the problem is that they can show up, and that feels like a bad thing. So it turns out that there's not really a best method. Instead, we just have to find the method that best works for the situation we're in. And the voting system that you use to pick where to go to lunch probably doesn't have the same kinds of problems that you think about than the one that says who should be a leader or who should uh, do a particular task or whatever. And voting systems should reflect the situation that you're in. So that's it. That's the whole course. This is the end of 7.3 to 7.5, and there are no more stuff. This is the end. There's no more. The homework and quiz are due at right before midnight on April 21st. Right after that, you've got the final exam. It's just chapter 7, by the way. Don't start panicking that it's going to have the material on like graph theory or the finance stuff. It's just voting theory. Please, please do the homework. Please finish the quiz. Please complete the final exam. It doesn't have additional weight, but you don't want to have a 0. If you have questions, please email me, message me, come to my office hours. Remember, my office hours are Monday, Wednesday, Friday, 12 to 1. Or you can, send me a message and ask to make an appointment. I'm pretty flexible with time. Either way, that's the end of it. I'm going to say have a great day, but more importantly, have a good end of semester. I hope that you guys all do well on your exams. And, well, that's me signing off for probably the rest of this whole course. Have a great day.